Good afternoon. I'm streaming, I think. So, yeah. Hi, I'm Toby. Welcome to Stream 1. Is there a chat here? I mean, not that I've promoted this and anyone will be watching. I don't know how it works. Anyway, without further ado, I thought I'd stream some solutions to Advent of Code 2024 using v4, Gamma, and VL. I enjoy doing these. I've never really worked through a whole Advent of Code, just like bits and pieces before. And yeah, I just kind of enjoy them as puzzles. Sooner or later, I always get overwhelmed. Some kind of esoteric for me, kind of graph solving problem or something usually stops me and I never come back to it. But we'll see how we go this year. In my personal life, I'm having a baby very soon, sometime in the next days. So I definitely do not expect to work through these in real time. But yeah, hopefully we'll get through the time. I'll find the time and get through them. Some goals when I'm working through the Advent of Code. So I'm obviously not trying to get on the leaderboard or something. I had a look at the leaderboard for number 1 today, and I think it's already the best time is 8 seconds maybe. I'm not sure how you view it now. But anyway, I had a look before. Yeah, here it is. Yeah. Oh, no, 9 seconds. So yeah, I don't see myself being able to compete with that, even though I like to say I think v4 is fast at certain things. It's not going to be faster than the time it even takes me to read the problem. So we're definitely, not trying to do this for speed. Instead, this is more about showing not just a solution, but how I work through a solution. And yeah, hopefully if you're just beginning with v4 or beginning with programming at all, you can see actually that I'll talk through each bit, and some of this will be very simple, just like string manipulation and things. Hopefully, could improve your vocabulary with v4, stuff like that. And also show fallibility that, particularly, hopefully not on day 1, but on some of these, I'll probably be getting some things wrong, and just show you, what it's like to work through things. And at the end, I'll upload the solution to GitHub, so you can have it. All right, let's start. So what I'm going to do is first, I'm just going to read through it. I'll read it out. And then I'm going to write what I guess is the solution. Before I even open v4, I'm going to think about what I think the steps are and just write that as a list. Okay, so day 1, Advent of Code 2024. The chief historian is always present for the big Christmas sleigh lunch. Let's zoom that in for you. But nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. What are we, like a historian security guard? As each location is checked, they'll mark it on their list with a star. We want to get all the stars. That's how Advent of Code works. You get some stars. Collect stars by solving puzzles, and when you solve a puzzle the first time, you get 1 star, and then they'll reveal a twist to the puzzle that you don't see until you've solved the first part, and then you can get the 2nd star. Usually it's something like there's an obvious solution to get the 1st star, but then, if you cheated, you did the obvious thing and you should have done the more complicated thing. You have to do that to get the 2nd star. You'll see. Okay, you haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into 2 groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, 3, 4, 4, 3, 2, 5, 1, 3, 3, 9, 3, 3. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, and then the second smallest with the second smallest, and so on. Within each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. For example, if you pair up a 3 with the left list with the 7 from the right list, the distance apart is 4. 7 minus 3 is 4. Okay. If you pair up a 9 with a 3, the distance apart is 6. In the example list above, the pairs and distances would be as follows. The smallest number in the left list is 1, and the smallest number in the right list is 3. The distance between them is 2. Okay. The second smallest number in the left list is 2, and the second smallest number in the right list is another 3. The distance between them is 1. Okay, showing us how these examples work. And then we're just adding up all those distances. And it's a distance, so it doesn't really matter if it's 9 minus 4 or minus 4 minus 9. It's about, the absolute distance between them. Okay, your actual left and right lists contain many location IDs. Yeah, so if you haven't done these, you keep this is the example, and you check the result again. So I want to process that and try and get 11. But the actual puzzle input you get is much bigger. So you really usually want a computer to do it. Although, yeah, I wouldn't rule out doing something by hand if the puzzle input was small enough. Okay, so now I'll think about how I want to do it. So for me, I think, yeah, first we've got to pass it. So, yeah, is that a tab or space between? Yeah, 3 spaces. So, yeah, first we've got to do a passing that will look for each number. Pass, I guess we can split by new line, and then split by 3 spaces, and then convert string to number. Oops, it's pass string to number, so we get those as numbers, and then, yeah, first number and second number into two spreads. Then we're going to sort those spreads. Maybe like a sanity check, the same length. That should be. Then what we want to do, yeah, is subtract one from the other and do an absolute. Absolute value, so that means if it's negative, so 3 minus 4 is minus 1. Oh no, it's not as simple as that. We want to, well, just do a distance. In fact, actually, I think there's a distance function. Oh no, it's correct. Yeah, 4 minus 3 is 1. 3 minus 4 is minus 1, but the absolute result of that, absolute just takes away the negative sign if there's a negative sign. Yeah, so that's correct. I got some doubt about it. No, I'm sure that's right. Well, we'll find out. And then, yeah, sum results. Yeah. Let's try that. Doesn't seem too hard. Famous last words. So here's v4 gamma. Using the latest stable, 6.6. So there was some fancy stuff coming through in the chat on 6.7. Haven't had a chance to open it yet, the preview with all these like docked windows and things. I thought, didn't want to be screwing around with that on the stream. Okay, so here's v4. And first thing I'll do, actually, is just save this. So what you'll be able to do is advent of code 24 help, and I'll call this how to. So it comes up as a help patch if I ever do this. How to 2024 day 1. Hey. Yeah, I think it'll be called advent of code in the help browser, so that's So the help browser, sorry, what I'm talking about. So if you've never seen v4 before, it's a visual programming language, and it comes with this help browser and all the packages. What I'll do, not today, but later, is release this as a package so that you can easily grab it via nuget, and then it will appear like this. So it'll be called up the top, Advent of Code 2024, TK Solutions or whatever, and then, yeah, you'll be able to search for these things, and you could search like 2024 day 1, and this would come up. Assuming you needed to search things. Probably what would be better is keywords related to the actual problem that's here to solve, but yeah, could do that as well. Okay, let's start working on a solution. So first thing I'm going to do is get that example, and we'll do a string IO box and just copy and paste that guy in. There it is. And I'll just notate that so I know example 1. Okay, now we want to do the parsing. So we have, for splitting strings, we have something called simply split string. Actually, I think there's already split to lines. Split to lines, I think, yeah, already does the new line. And so what that does, you can see now that's another structure saying there's 6 results for the 6 lines. So that's turned it into an array, but there's still strings on each line. And what we want to do is split again. Split string. Oops. And now to spread, what we have to do actually is process this on a per element basis. The spread's like an array. It's kind of the v4 word for array. It's like a little bit safer than an array if you're familiar with arrays. So you never get an overflow error. It just like wraps around. If you try and access an index beyond its length. Separator is 3 spaces, isn't it? I think so. 1, 2, 3. So, yep, 3 and 4. And then I think I can already unzip. Yeah, unzip is a cute way to get things. If you already know there'll be like 2, you can get 1, 1. Oh, except there it spreads. No, I want single elements. I think, what's this way to do this? I'm just going to use getSlice. GetSlice 0. Oh, do we have decons? No. Sorry, decons was a way you might have done that in the old v4 beta. Okay, getSlice 1. So value that's 0 is there, and value that's 1 is there. And then we want to pass that value. Try pass. Yeah, try pass. So try pass is generic, and it wants to know what value to use, and very common also that they use integers. Oh, let me check, is it definitely 3 spaces here? Yeah, great. Yeah, lots of Advent of Code problems are integer based, in my experience. So I think we only need to turn that into an integer. So if I put an integer IO box there, that'll confirm that. And so it's turned from a string into that as an integer, and now you have 2 spreads. Great. Then we want to sort both of those. Now it said sort from lowest to highest. I wonder if that matters. It just seems like they should be in the pairs. Well, the sort is ascending anyway. Okay. In this example, 3, 3, 3, 1, 2, 1, 2, 3. Yeah, 1, 2, 3, I'm seeing, and 3, 3, 3. It's okay, sanity check. Yeah, so I think those spreads have got the correct thing in them. Now we'll do another for each. In fact, I probably could have kept it in this for each. Oh no, sorting. I needed to sort. Okay. You should have the same count. I might just put another sanity check here. Otherwise. Alright. So 1 minus the other. And we go absolute. Just the AVS operation. Now we have a bunch of results. And then I think we have some thing that'll operate on a spread will operate in a sequence, and the spread is kind of sequence, and the result is 11. Okay, and that's the result here. Great. All right. So now what we're going to do is get the data, the actual thing. However, what we want to do is put this in a cache because what we were looking at before ran every frame, which was great for debugging it. But if it runs every frame and we give it a very large input, that could be very slow. So there's example one, and these border control points. So I've just created this cache region, and basically it means it will only update the stuff in there, and we'll see when it updates if we look at that box. It'll only update the stuff in there when something on this input changes, and we can also force it if we want. And so simply by getting the next bit of data, puzzle input, and connecting it, it should calculate that once. Okay, so Control A, Control C, back here. Oh, there's a function so you can see my keyboard shortcuts. I should turn that on. Okay, there it is. Very big. Let's pop it in there. It says the answer is that 164652. My answer, by the way. So all the puzzle inputs are unique for each user. So that way you can't just copy somebody's answer directly. Yay, we did it. Okay, our first gold star. We need to find that chief historian. Okay, part 2. And you can see actually this is just extending part 1. So part 2. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree. Historians can't agree, what a surprise, on which group made the mistake or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that each number appears in the right list. Okay, sorry, I should make a note. This is 1A, 1B. The same example. So what do we do? First number in the left list is 3. It appears in the right list 3 times, so the similarity score increases by 3. 3 by 3 is 9. Okay, so it's left list, number, check occurrence in right list, multiply left list number by occurrence, sum this is similarity score, sum the similarity scores. Okay, so this, lists, spreads, arrays. What we could do here is, okay, we've got 3, and then we're going to check 4, 3, 5, 3, and we just iterate through the array. That's quite slow when you've got a lot of things to do, and then we've got to do it for every single element. There's also this thing where some of the elements are repeated, but I'm not sure. Obviously here we've got 3 and 3, 3 occurrences of 3 in the left list, but given the numbers in this list, I'm not sure if any of the things in the left list repeat. Anyway, there's a data structure that's called a hash set. A hash set is very fast for looking things up. So if I ask the hash set, does something appear in the right list, then it will be able to tell me very fast if it is. But what we lose with a hash set is we lose the count. So, and we know numbers are repeated. So you add something to the hash set, it gets hashed, which makes a unique value, even though it already is a unique-ish value. If it gets hashed, then we will, that hash can only be added to the hash table once. So we need to do something a little more sophisticated. We need to turn the right list into a dictionary, which means a dictionary is kind of like a hash set, but appended with extra data for each item. So what we can do is right list, yeah, turn into dictionary. Key is based on the value, so the key in the dictionary is like this value in the hash set. Same thing. So 4 will be the key, or let's say 3 will be the key because there's multiple 3s here. Then it's processing this list and turning it into the dictionary. It'll say, okay, we've got 3. Add that to the dictionary. And it'll create a new entry that's like, okay, for key 3, and I'll make sure the default data is default. Key is based on list element. Default value is 0. If the key already exists, increment the dictionary value, which means when it gets around to processing this one, it will say, okay, we need to add, yeah, 3 already exists. So what we'll do, because it can check the hash set very fast to see that 3 already exists, and then we will increment it by 1. Okay, this might be confusing. I'll explain it all again when we've checked this solution actually works. All right. So let's save this. How to day 2024 day 1B. All right. So I'm going to go back to my example, and I'm going to run this every frame so that because with such a small data set we can, so that I can quickly debug it. Okay, so this is running, and if you mouse over, see it's got that like picoseconds that shows that it's running. I was going to show you my keyboard shortcuts, right? Let's bigify this so it's easier to concentrate on. There's an extension, key and mouse display. Oh yeah, you can see it down there in the bottom left. Shows you I'm right-clicking and dragging. Okay. So right list we need to turn into a dictionary, and I think yeah things are different here more or less. So the right list gets turned into a dictionary, and we still iterate it to do that. So for each right list item, and we need a certain kind of dictionary. This is another detail. When you're processing this much data, you actually want to use a mutable dictionary, at least at the start. And so this is something that's called a DictionaryBuilder in V4 is the mutable dictionary. I think there's also a mutable dictionary. And I'll have to turn on the advanced part in the node browser to see this. DictionaryBuilder. So first thing I want to do is clear the DictionaryBuilder every time this runs. Dictionary. And then I want to add, it's like if exists. Okay, there's probably, so when you look at the dictionary operations that belong to the type DictionaryBuilder, I think there's always some shortcuts, like I can use add, and add will give me an error if it already exists, but set, I think, also adds if things don't exist. But I'm just going to do it the most verbose way to make it really obvious what I'm doing. So we kind of are going to try and see if try get key. Yeah. So what happens? First thing, this value comes in, and then this is the dictionary. And if you are new to V4, you might be wondering about these border control points. I guess I haven't explained that on these. Oops. First, we're going to see if this value exists in the dictionary. And the difference between these two border control points, this one for each, that's actually iterating, yeah, for each value in this list, that like trapezoid. I'm going to access that each time this loop runs. This one, the diamond, that means that I'm going to access the exact same dictionary builder. I even don't strictly need it, but it makes it clearer if I add it. It means I'm accessing the same dictionary builder every frame, as opposed to the trapezoid, which means I'm accessing a different value in the list every frame. So we're iterating over that list, but in this one, inside that loop, we're accessing the same item. It's called an accumulator, by the way, the diamond. And what's this one called again? Name escapes me right now. Anyway, okay, try get key. So if, and this is still faded out because I haven't told this thing everything about the types of the value in the dictionary yet, but that's okay. result. So yeah, if not, that's the first case we want to do. So if the value is not in the dictionary, then we want to add it. Dictionary builder. Add. Alright. We select those and go Control L. We'll make them a little bit neater, which I like. Okay, maybe I'll just put this here and call this right list element. Okay, so we want to add it and it'll be the key. Then we want to set the value of the dictionary, the like payload of the dictionary, initially to 0, but I still need to specify the type. So it'll be 0 when we first add. We're talking about number of counts. So actually, more correctly, that's 1. So that's count. Okay. Occurrence count. Now, whoops. Dictionary builder, let's say what happens when the value is. So this if block is going to trigger when the result is true. If the value is already in the dictionary, then we don't want to add it. We want to get it, which I could have done in one operation up here, but again, it's clearer what's going on. So we get it, and then we set it. So on that key, which is 4, assuming it already exists, we get it. Dictionary builder, oops, set item. Again, we want to set the item at the same key. So we've got, well, it says key 3. Oh yeah, because this is only running actually, already it's only running a second time. This is the first time it runs a second time. So we're seeing 3 in here. And what we want to do is increase the value. I think there's one inc. Inc just does like ++, or if you're used to programming in code, you do like 3 equals 3 ++, or x equals x ++ to increment things. This does something else, it just adds 1 to it. But again, for beginners, just to make this really clear, obviously I can just do a +1. All right, is that clear as mud? So we've built now this dictionary. Now it's still a dictionary builder. And what we like to do is make, that's a mutable type. What we do is like to make it mutable. We like to make it immutable, I mean, so we use this to immutable, and now it's a regular dictionary instead of a dictionary builder. Doesn't matter a lot, to be honest, because it's pretty clear the provenance of this thing, but it's better programming generally for the way v4 works with this kind of data flow context to work with immutable things by default. Because, yeah, if you're working top down and you like kind of split something into 2 forks, if it's immutable, then each fork operates independently. All right, now for, this is the second part, for each item in the left list, what we want to do is check its occurrence in this list. So dictionary try get value. So that's dictionary. We're going to try and get this key. And then we should have this, what they call a similarity score, which is the number of occurrences in the dictionary. And if we don't get it, just to be explicit, if we don't get it, the value should be 0. So sorry, if it can't look it up, the value is 0. I think it would be anyway, but let's just make that explicit. Oops. All right. So now I'll put that there, and this trapezoid shape as the border control point on the bottom of the for each region puts things back together in a list. So this takes the input of a list, goes through each item. This puts them back together in a list. And I think I meant to sum that again. And I get 10. Is that correct, or have I messed it up? No, the similarity score at the end of this process is 31. Definitely wrong. Ah, multiply. Forgot. I should read this. Classic mistake. So we take the left list number and multiply it by the occurrence. Sorry, yeah, that's the similarity score. Yeah, integer by integer multiplication should always be an integer. So just to check, as soon as you're multiplying or dividing integers, actually, yeah, maybe you need a float to support that. Yeah, okay, this is 31, it says. All right. So last step, we're going to not run that any frame anymore. This would be very slow. Now we're going to put in a huge puzzle input instead. It should automatically run at least once, and now we get our apparent result of that number. Let's see if we got it right. Submit. Ta-da! Gold store. Completed day one. So there you go. Okay. I feel like I didn't do a very good explanation of the hash set and dictionary. I actually already have a video on this on YouTube, I think. Let me have a look. Oh, sorry for the bright white screen. I should make this dark mode. Collections in V4 Gamma. So actually, I've already explained it, I think, better than I'll be able to kind of improvise an explanation right now. So if you're confused about hash set and dictionary, check out this video, Collections in V4 Gamma, on my YouTube. All right, so let's see. I'm going to watch back this stream in a minute and let's see how it was. 32 minutes. Yeah, seems okay. Thanks for tuning in for episode 1, and talk soon.